Okay, now we're going to look at something interesting. We're going to look at angles of any magnitude. Where we are restricted in a triangle, we can't get angles more than 180. We're hard pressed to get them less than 180 and more than 90, aren't we? So let's have a look and see what happens in a circle. If I draw myself a circle with a set of XY axes straight through the middle, and on top of that I decide that this circle is a unit circle, which means it's going to have a radius of 1, I'm going to find some interesting things. So let me say I've got a point here on the circle. That point there, it's got an X coordinate and a Y coordinate. Let's say I drew that at 30 degrees. Now because this is a unit circle, I know my radius there is 1. One thing we're going to have a look at is this triangle. Let's zoom this triangle. Well, where's the triangle, you might say? Well, here it is, look. Let's zoom this triangle up. So I've got this here. It's 90 degrees there. And it's got this side as a value of Y and this side as a value of X. Now let's see what's going on there. We know the radius is the same as the hypotenuse. And even though I've put a particular angle there of 30, let's just put a general one here of theta. Let's investigate that triangle for any particular theta. Let's look at cos theta. So cos theta we know is adjacent over hypotenuse. Well, that's just x. Let's investigate sine theta. Sine theta, opposite over hypotenuse. Well, that's just y. So what I notice is that all my x values when I'm on that circle, unit circle, are going to be the same as the cos of the angle. And all my y values are going to be the same as the sine of the angle. So that's quite interesting. Let's have a look and see where that is on this diagram here. So there's my particular x value there, and it's that length there. And here's my particular y value there, and it's that length there. All right, we'll see that point there. I can rewrite it now. This point here, not only is it x comma y, I could also call it cos theta comma sine theta. So with my particular one there, I have drawn it at 30 degrees. So we need to know what cos 30 and sine 30 are. Now do you remember that special triangle? Let's just draw it over here, out of the way. It's 2 there, it's 1 there, it's root 3 there. We have 30 up there and 60 down here. And I'm interested in 30. So let's look at that. What's cos 30? So cos 30 equals adjacent over hypotenuse. So instead of this cos 30 over here, see I'm rubbing it out in that coordinate, I'm now going to write root 3 on 2. Now what's sine 30? Sine 30 is opposite over hypotenuse. So I can rub this out now and say that that's 1 over 2. So where's that on this diagram here? That means that that value there is root 3 on 2, and that value there is a half. Even though my diagram doesn't look very faithful to a half, it's a bit dodgy, I agree. So that's the interesting thing here. Cos 30 is root 3 on 2, and that's there. And sine 30, which is a half, is here.